Good afternoon and welcome to our webinar, Making Effective Use of Storage Virtualization. My name is Kevin Cook and I'm a Market Development Manager with Terakai Corporation. Today I'm pleased to introduce John Bossart. John is an industry leader on the topic of virtualization, server, and storage technologies and will present on how to more effectively manage your storage infrastructure to support virtualization. Without further delay, welcome John.
Hello everyone. Let me bring up my presentation real quick. All right, so my name is John Bossart. I'm an overall industry virtualization expert. I certainly can talk to all forms of virtualization. Today we're going to be talking about more specifically storage virtualization and how you can really use this in your environment to really make some impactful changes to the process and what you're doing. So whenever you evaluate new technology for your environment, you should always kind of look at this rule that kind of exists. The numbers kind of fall around is most of you guys out there today are spending about 70% of your time doing things that are to keep the blinking lights kind of flashing within your IT back room. And you're only really spending about 30% of the time really introducing new things into your environment that create innovation within your infrastructure. Whenever you look at any technology around virtualization, you really want to look at it as a way of kind of tippling this pendulum and kind of reversing the numbers, if you will. Make it more about introducing new operations within your infrastructure instead of just keeping the lights blinking. That being said, your storage needs really continue, and even in this downturn in a bad economy, and we're kind of come out of this bad economy, but still, there's a lot of lessons to be learned. And one of those lessons to be, you really never stopped generating data during that time. And the number that I kind of have here from IDC is the digital universe is 10 times the size today as it was in 2006. So your data grew at 10 times the size it was of just 5 years ago. So you're always continually creating and generating data, and we need to really figure out a way where we can manipulate and manage this data, or more importantly, really make sure that our data is not coupled to any physical piece of hardware within our environment, kind of the same way we did server virtualization, or when virtualization technology first came out. We did machine-based virtualization. We decoupled our applications and operating systems from the physical hardware, but now we need to apply that same lessons that we learned from that technology and apply it to our storage. So your business objectives really should be to build an infrastructure that's dynamic. It can adapt to changes within an economic climate, and it's something that should be there to help you drive your business. The environment should be easy to manage and provision. Everybody needs to do more with less. We are always finding, especially when we, the lessons that we learned over the last few years, is that we need to figure out how to do better with the resources that we have, and certainly storage virtualization is going to help you to do that. And finally, business continuity. We need to figure out a better way to do business continuity. I know a lot of us look at our strategies that are out there. Maybe we have tape backups that kind of exist. Maybe we're copying files at certain times of the day. Maybe we're doing SQL, database mirroring, where we're setting up some type of Microsoft clustering. But the moral is we're doing business continuity in a variety of ways within our infrastructure. Isn't there a way we kind of wrap this business continuity underneath one umbrella? And we'll talk a little bit about that throughout this slide deck. Now, certainly the concept of virtualization is nothing that's new. It's been around for a long time. I think the earliest forms, in my eyes, of virtualization has certainly been network virtualization. We have VLAN technology, which has been around for a while. And if you don't know what that is, that's a way of kind of creating a virtual switch that can span and separate amongst multiple network switches in our environment. So it can actually divide traffic up and keep it segmented across multiple systems. There was also a time when we didn't have a converged network, meaning that we had different cables that ran in our environment for phone traffic as well as network traffic within our infrastructure. But now we run both our telephony traffic as well as our data traffic over one cable within our infrastructure. So that was network virtualization. And certainly we all know about server virtualization. We certainly should look into that for our environment that you haven't already. Server virtualization allowed us to decouple our applications of our hardware, run multiple virtual machines on one physical host. So it allowed us to do a lot more with less. Taking these two kind of concepts that you think about when you think about some of the network virtualization topics that I talked about, as well as the server virtualization, we've kind of put in an abstraction layer between our information and the hardware that it was associated with. And the same thing you're going to find is going to be true with storage virtualization. So let's kind of look at this. I grabbed some quick quotes from Wikipedia. I think Wikipedia, although it's not the best source of information as far as things that I can quote, but I think Wikipedia represents what the general consensus is of a technology or a topic that's out there. So with hardware virtualization, it's the execution of software in an environment separated from underlying hardware resources. How about data virtualization? The presentation of data as an abstract layer independent of the underlying database system structures and storage. And finally, storage virtualization on the bottom. The process of completely abstracting local storage from physical storage. So if you look at all these kind of quotes, what we're saying here is that we're kind of inserting an abstraction layer between your information and the hardware it sits on. And like I said, we've done that with network virtualization. We've done that with server virtualization. It's time to look at storage virtualization and decouple our data, our important ones and zeros that exist on our storage, and decouple that from the physical piece of hardware that it's on. So some questions you should ask yourself about your storage. Where does your storage come from? How important is that data? How accessible is it? If something happened within your environment, could you still get access to that data? So, which kind of lends itself into, is that data safe? Right? If something happened, something catastrophic, a fire happened, or a natural disaster happened, how safe would your data be? How long do you need to keep that data? There's been a lot of regulatory compliances that have came out there that have told us that we need to keep our data for a lot longer periods of time in our environment, or you may have some other company mandate that says you need to hang on to emails over a certain period of time. How do you deal with that storage? It gets very expensive to manage storage in this fashion. And we find ourselves a lot of times putting local storage inside our compute equipment that we're deploying today, inside our servers that we deploy today. We buy a server, we load it up with as many hard drives as we feel we're going to need tomorrow, and we deploy our application and data onto that server, and then we just kind of watch it grow and hope it never fills up that environment. So what I want you to think about when you ask yourself these questions is, how would your business be different if all your data was consolidated, if all your data was centralized within an environment? So which brings me into shared storage. Shared storage is a way of consolidating your data in your environment. So shared storage is any array that has a common set of interfaces that can be accessed by multiple servers in the environment. I'll go down to the bottom of the slide. So the three main concepts of a SAN is a host bus adapter, so something you put inside your compute device, inside your server. Switches, you can think of them, and many times they are, the same network switches you're using on a day-in and day-out basis. And then a storage array. So this is an external box that has a little bit of intelligence, that has a bunch of hard drives on the internal. So there are a few different connectivity types for shared storage that's out there. Currently, the highest performing solution that exists is Fibre Channel. It is the fastest, but of course, with performance, there certainly is a cost associated with it. A lower cost solution is Iscsi. So Iscsi can certainly achieve similar performance to Fibre Channel, but at a lower cost structure in an environment. And the nice thing about Iscsi, which also helps to lower the cost, is we're using off-the-shelf host bus adapters, which just happen to be network interface cards that we're using day in and day out, and off-the-shelf network switches as well for an environment. The next solution that's out there is SAS. We've probably heard of SAS. This is the current hard drive technology that we find most common in the servers that we're using in our background, in our IT back rooms today. When the concept of SAS first came out, there was a concept of a hubbed architecture, meaning we could have multiple systems connected to the same storage. The only problem with that technology, it hasn't really taken off. You haven't seen a lot of implementation on it, and mainly it's limited in the fact of the amount of hosts that can attach to it. So shared storage as far as SAS usually is only 2 servers. For maybe like a Microsoft clustering type of solution. I have seen some solutions that have tried to expand that out to 4 servers or so, but it's really not a very popular solution. There's not a lot of back end to it, and there's not a lot of the high end features that I'm going to be going through in this slide deck that you're going to see associated with SAS storage. Finally, there's network attached storage, or a NAS. A NAS is another solution that connects to our network through traditional Ethernet and network switches within our environment. But the limitation with network attached storage is that it's not really block level. Meaning, if we were looking at Fibre Channel or Iscsi, and say we had a database on that shared storage, and somebody went into that database and changed maybe a 1 to a 10. So they just added a 0 to a number. Well, with a NAS type of solution, I would have to send that entire database over to a backup solution that kind of existed. When I look at Iscsi solutions, when I do a backup or do a replication of, I'm only sending the delta or the difference. Right? And that's the difference between a block level and a file level backup. NAS devices are pretty much file level devices, and Iscsi devices are pretty much block level devices. So Iscsi and Fibre Channel are really the solutions you probably want to look at inside your environment. They're really going to offer you the most return on investment for your infrastructure. Not to say that these other solutions don't have a place, but when you evaluate these solutions, I would steer towards Iscsi and Fibre Channel. So when you look at your environment, you need to decide when do you need shared storage. And I've got a few things listed here. You're doing wide clustering support. You have a bunch of Microsoft clusters that kind of exist in your environment. It makes sense to attach to a shared system that can be shared amongst multiple servers. In the past, when we did Microsoft clustering, we've kind of had 2 servers to 1 external storage. That's incredibly expensive and ineffective. Server and desktop virtualization. I got a slide. I'm going to talk a little bit more about this. It's safe to say that if you've got a virtualization strategy and you don't have shared storage, you are not really taking the biggest advantage out of your virtualization practice. You need to control exploring storage costs, which kind of goes into better disk utilization in the bottom line, caught in the more trap. So we tend to, in our service today, buy the storage and install the storage that we need tomorrow. Right? When we look at shared storage technology, we have the ability to buy the storage we need today and expand it tomorrow when we need more storage. Right? And if we have individual hard drives inside servers, they become very difficult to manage. Inevitably, we're going to come to a point in time as to when I wish, I loaded up a server with a terabyte of space, and my other server only has 500 gigs of space, and I wish I could take some of that storage and move it from one server to another. When we put physical hard drives inside servers, I can't move that around. When we talk about shared storage technology, I have the ability to move that around on a whim. And finally, shrinking backup windows. A lot of us have, when we started building out our data centers, maybe we bought a server and put a tape drive in it. We bought another server and then put a tape drive in that as well. After we did that enough times, we realized it was inefficient to send somebody around to change tapes all day long. So we kind of centralized our backup strategy. So we set up a backup server and we pulled our backup jobs across the LAN in an environment. But when we did that, we created a little bit of congestion on the network. We couldn't do a backup whenever we felt like it. We had to wait till the weekend or wait till at night or some type of lull in network traffic to be able to do our backup. When we look at shared storage type technology, I can actually do backups across the shared storage network instead of across my production network. I can actually do backups across the replicated storage in the environment instead of across the network infrastructure. And that also adds a little bit of efficiency. It kind of opens up my backup window to as large as I need it to be in the environment. We'll talk a little bit more about that as we go through the slides. So you need to evaluate when you need shared storage in your environment, and certainly these topics are things you want to look at. So I already said that if you're using virtualization technology in your environment, you're not using it with shared storage, you are not achieving the most return on investment as far as your virtualization practice is kind of concerned. Today's virtualized solutions have a lot of availability built into them. Anybody's solutions you're looking at today, from VMware to the other vendors that kind of exist, will have a live migration technology, or a vMotion technology, as VMware likes to call it. And that's moving live running virtual machines between physical hosts without any downtime. Meaning that if somebody had an email server, right, you could be updating, context on the email server, sending out an email blast, whatever you normally do with that resource on the network, while it moved from one host to another without any downtime. And this makes a lot of sense. If we need to do physical maintenance on that host, the physical host in that infrastructure, right? So gone are our planned system downtimes with our environment, and IDC tells us that about 90% of downtimes are planned system downtimes with our infrastructure. So think about when an application went away inside your environment. If we combined shared storage technology, we virtualize our storage, and then add virtualization software such as VMware on top of that environment, we can create really an environment that's resilient to things that can happen on our network. especially in the case of high availability, meaning if I have a bunch of virtual machines running on a physical host and that host fails, those virtual machines will automatically, without user intervention, power up on another physical piece of host. And this can only happen because our virtual machines are just files that should exist on some type of shared storage. And you can, and certainly I've only got 2 topics kind of listed here as far as virtualization and shared storage is concerned. But really, when you look at your storage, when you look at your virtualization software, to really do anything of any great interest with that software, you need to have shared storage in place in order to take advantage of it. So I'm going to go through some hot topics that are found within current storage technology. The first of which is data deduplication. So the way I like to describe data deduplication, and this is found quite commonly in a lot of the storage solutions, shared storage solutions that exist. So if today I wanted to send the copy of my presentation, which is about 5 megs, to 100 people at Terakai, once I emailed my copy of the presentation out, it would make 100 copies of that in everybody's email box in there. So that's about for 100 people, that's about 500 about 500 gigabytes in the environment, or 500 megs inside their environment. So it takes up a lot of storage space when it's the same copy of everything that kind of exists. When I do the same thing in a data deduped environment, what happens is that gets sent out once. The storage recognizes that there's 100 copies of the same file, 100 copies of the same ones and zeros that exist in the storage, and consolidates that down to one storage space in the environment. So now, if I email my 5 meg presentation to 100 people or 1,000 people or 10,000 people, it only takes up really that 5 megs on the shared storage in the environment. And that's how they kind of get to numbers where they see deduplication ratios of 500 to 1. You might see after 6 months. So they use, my example is kind of rudimentary example. They kind of use that type of technology as well as compression style technology on shared storage in order to achieve this deduplication number that we're kind of talking about. No matter what, we're saving a lot of space in our storage. We're kind of virtualizing the amount of space that we have to work with. This also helps us to be able to do backup strategies as well. So a lot of storage technologies will have replication features, meaning that if I have 2 storage arrays or 2 storage enclosures in my environment, whatever's in the first storage enclosure can be automatically copied to the secondary storage enclosure, and that's just called replication. You'll see that quite commonly. We'll talk a little bit more about that as these slide decks kind of go. But this replication kind of happens between 2 storage enclosures, and I can take this storage enclosure and put it at a disaster recovery site if I wanted. Now, in my scenario where I sent out my email to everybody, if I was in a deduped environment, I have to send all that data over the wire to the replicated storage. But when I talk about a deduped storage, I'm sending very little over the wire to the secondary storage. The next solution that's a hot topic that I consider a hot topic is thin provisioning. So without thin provisioning, if I take and create and show a server environment a thick provision 20 gig hard drive, it will take 20 gigs of storage on my shared storage. But if I use thin provisioning and I carve out a 40 gig partition to show a server, and its data only uses 20 gigs, right? In a thinly provisioned environment, it's only going to take 20 gigs of storage on my shared storage piece. The same thing is true in the graphic here. If I thinly provision 100 gig and only use 40, I'm only going to use 40 gigs of that storage space. So I have actually provisioned it in this example, let's see, 160 gigs of storage, but I'm only using half of that within my shared storage environment, allowing the rest of the space to be used for other applications that kind of exist in the environment. So there certainly is a risk at over-provisioning an environment and running out of storage space that kind of exists. But with today's technology, you'll get alerts that you're reaching a certain threshold, and we can grow our storage by either adding extra hard drives inside an enclosure or adding extra closures to our overall shared storage solution. So we can grow. So we can actually provision the storage that we need today, but purchase what we need in the future. Another hot topic is snapshots. So this is the ability to take a snapshot in time or freeze my data at certain intervals. For example, if my data exists as a bunch of ones and zeros that exist on shared storage, and I take a snapshot of it, it freezes those ones and zeros in time so they never ever get changed. And when we freeze that, we don't stop write traffic from happening. If it happens to house a database or an email server, traffic is still flowing into that repository for storage. It's just getting written to a separate space on the shared storage, on a delta section or a set of delta blocks that are in the environment. And I happen to take another snapshot. It's going to freeze those delta blocks and write that again. So, for example, say I have a D drive that contains my email server. The entire D drive will consist, in the example that I gave you, of the first block of storage and the 2 delta blocks of storage. But the interesting part of this is, say after I took that third snapshot or whatnot, say the system blue screened for one reason, and I applied a service patch, or somebody made a change or something like that, and something catastrophic happened to the server, I can revert the snapshot to yesterday's snapshot and bring that server back up and be back in business again within my infrastructure. Also, snapshotting technology allows me to be able to mount these snapshots to maybe my backup server and do a backup of that. Again, we're freezing in time my data while it's getting written into a separate space and doing a backup job of that frozen data. So it really opens up my backup window. So for a backup job that's going to happen across the SAN infrastructure instead of across the LAN infrastructure without impacting the performance that I'm going to see from my storage to my network in my environment. The next solution, hot topic solution that's out there, is tiered storage. Now, I'm going to talk about the different types of storage technology that exist today. And the first of which, and probably one of the hottest topics that's kind of out there as far as storage is concerned, is Ssd drives. I'm sure a lot of us would love to have Ssd drives in our home system. But if, as maybe some of us done some research on them, we realize that they tend to be the most expensive hard drives that kind of exist out there. But they are certainly the fastest performing set of hard drives that kind of exist. But they also are the smallest hard drives, smallest price per meg that kind of exists there, or smallest price point per gig that kind of exists out there. So the drives tend to be very expensive, small, but they are very, very fast in the environment. The next solution that kind of exists is Fibre Channel, or more commonly, SAS disks in the environment. So these are the type of hard drives we've been putting in our servers for a long time. They represent the best price per megabyte or gigabyte to our overall storage solution that exists in our environment. They're a very fast solution. The drive sizes are of a nice size, and they represent a good cost point. On the lower end side of things are SATA disks. Now, SATA disks are the lowest cost solution that kind of exists, but the drive sizes and capacities are very, very large. But they don't perform as quickly as SAS disks or SSD disks in the environment. Now, I bring this all together to show you that really, wouldn't it be nice if our storage technology could take advantage of all three of these hard drive types within the shared storage enclosure? Meaning that if I deploy a partition to a server in the environment, maybe as a default that storage got provisioned on SAS drives, and all of a sudden it needed more performance, the storage enclosure would automatically move that data from the SAS drives to the SSD drives. And it won't necessarily do that on a file system level, and it'll actually do that on a block level, really from underneath the file system in the infrastructure. So even if you had a portion of a database that was getting hit quite extensively, just that portion, or just those blocks that were getting accessed frequently, will get moved over to SSD drives. And we can look at things in the other fashion as well. Say where I'm using some storage for backup solutions, so it gets accessed not very frequently in an environment, or it's archival purposes. Well, that would start to get moved from SAS drives down to SATA drives in the environment. So our data has the ability to migrate around within our shared storage solution and provide the performance that is needed for the network when it is needed. The next topic I'd like to talk about is RAIN technology. So a lot of us currently have been doing redundant arrays of independent disks or RAID technology within our servers, and that's the ability to have multiple hard drives within the server to act as a single entity, or act as a single storage, and provide a little bit of high availability within our environment. So we're no longer afraid of if any one of the hard drives fails within our server, our server stays up and running. This technology has kind of been moved over to storage, shared storage technologies, and we call it RAIN technology, or redundant array of independent nodes that exist. So it works pretty much the same as disk technology. So if I have two storage enclosures out there, I'm pretty much mirroring my data from one storage enclosure to another storage enclosure. But most of the storage solutions that are out there, and I'm really talking about a lot of Iscsi solutions that are out there use this type of technology. But most of these Iscsi solutions will maybe have 2 gigabit connections per enclosure. So 2 gigabit connections can be bonded to make a 2 gig pipe in an environment. And when I stack on or my secondary enclosure, I get another 2 gig connection. The solution will actually take all 4 of those 1 gig connections and make one big pipe. So now I got a 4 gig pipe come into my storage in my environment. So something that's comparable to Fibre Channel storage can now be accessed within our network just by having 2 storage enclosures that kind of exist within an environment. And my data is protected. So if one of these, one of these enclosures happens to fail or will not boot again, I still have a secondary copy. If I had the 3rd storage enclosure in this environment, again, 2 network interfaces, now I got a 6 gig pipe coming into my shared storage. But now I can do a RAIN 5, which again is similar to RAID 5. So 2 of these storage enclosures would have my disk space would be equal to what the space in 2 of these storage enclosures. But I'd be protected if any one of these 3 storage enclosures failed. Right, I'd still have my data available to my network. The graphic that I have here has an overall total of, let's see, oops, back up here. So I have 6 storage enclosures, so that would be a 12 gig pipe coming into my network, and my data would be equal to my storage space, my raw storage space would be equal to the amount of hard drives that I could put into 5 of these storage enclosures. So this type of solution allows you to start off small and then grow much larger as your business demands, not only as in throughput to your storage, but as well as the size of your storage that you need for your environment. Again, you combine this with thin provisioning. You can give your servers the storage that they plan to use tomorrow, but not have that allocated in the back, right? And then when you need it, or next year when budget comes free, you add another one of these nodes into the environment and expand your storage needs. We talked a little bit about replication, and that is the ability to take a couple storage enclosures, put them in 2 different areas, two different buildings, or 2 different cities, and replicate the data from one side to the other. And that's called array-based replication. So this is an exact duplicate of your production data. So whatever's happening at the main side, all the 1s and 0s, as they change, get automatically replicated over to the DR side. So this is kind of an interesting perspective, especially when we talk about doing backups. Because now instead of doing backups at my production data center, I have a backup meaning that it's been replicated. But if I need to offload the tape to move something off-site or archive it, right, I can do that at my DR site instead of in my production environment. So it can help us reduce the DR cost of the infrastructure as well, because now I'm kind of holistically doing a backup strategy in my environment. I'm replicating my data from the main site to the secondary site. Again, we could use snapshotting technology along with this to kind of freeze our data in time as we replicate this from one side to the other. But it allows us to kind of have a holistic view for our backup strategy in our environment. If all our servers of all our applications are being accessed through shared storage, I can replicate that information holistically, data center-wide to the remote site. And this becomes even more true when we combine this with virtualization technology. So virtualization technology takes their operating systems and applications and condense them down to a file. And if we think about it, now that they're a file, I can copy that file from one side to another and open that up on the remote site as long as I'm running the same virtualization software. The analogy I like to kind of give people is kind of a Microsoft Word analogy. If I'm writing a Microsoft Word document and I save that file and I open that up at home from a different computer, maybe I use an HP computer at work and maybe I use a Dell computer at home. Last year's Dell computer, I still expect to open that file and get back in business again at home if I need to. And the same thing's true with virtual machines. My virtual machines just exist as files on the shared store. If I copy them over to the DR site, right, I can really make a low-cost solution for setting up a disaster recovery strategy by as I decommission servers at my main site, I can move them over to my DR site and attach them to the same shared storage or the replicated shared storage in the environment and bring up my applications or my virtualized machines in the worst case scenario. So again, it takes that holistic view of doing disaster recovery to your entire data center instead of having these onesie twosies type of backups. This is my SQL mirroring. This is my tape drive backup solution. I'm doing a I copy these files at night to this server. Things like that kind of go away. I have one backup disaster recovery and backup solution that encompasses my entire environment. And you need to ask yourself, how important is disaster recovery in your environment? Well, first of all, if you lose your data for 10 or more days, you're probably going to go bankrupt within your environment. All right, so maybe it'll cause you maybe go back and look at your data and think about how you're protecting it. And the people who are protecting their data today or have some kind of business continuity strategy today, you're a little bit nervous of what would happen if you had to deploy that solution within your environment. And that's probably because that you had a real limited budget to be able to dedicate to this, because you're really just buying that insurance policy in case something happens. So a lot of the people who are holding the purse strings for these type of solutions, they're afraid of how much this type of solution is going to cost. When you combine storage virtualization along with server virtualization, you're really, again, creating that replication strategy or that backup strategy in a holistic nature for your entire data center. You could use certain technologies like live migration or high availability that's found in most virtualization solutions to create a level of local high availability. So if a server goes down, all those virtual machines power up on the secondary node. If the site goes down, you could bring up the remote site. And it doesn't have to cost you a real lot. As long as you replicate your storage from one site to another, you can use last year's servers as long as they can run the same virtualization software at your DR site and bring your applications back up and running. So those are some of the hot topics that are kind of out there. I want to talk about other solutions that exist that are different types of ways of abstracting our storage solutions in an environment. The first of which is a virtual SAN appliance or a VSA. So if you look at a lot of the storage solutions, you crack open the box of the array enclosure or the shared storage enclosure, and you look inside, you're going to see a bunch of hard drives. You're going to see some memory. You're going to see a processor in there. Components that are quite typical of what you see in a normal compute environment, a normal server, a normal computer that kind of exists. So why couldn't we, in that case, create a virtual machine as our shared storage in our environment? And that does exist today, and it's actually called the virtual SAN appliance. So what kind of happens in this environment? In this graphic, I kind of have the ESX server. In that ESX server, I put a large amount of hard drives internally to it. And then I create a virtual machine, the VSA, and I make that and I show it all that storage, and I make it represent that storage back to the network as Iscsi traffic that's in the environment. Now that's only good as long as I have that one ESX server stays up and running. But what you should do with this type of technology is do RAIN, or redundant array of independent disks, or spread that information across. In the graphic I have here is 3 hosts. So 3 hosts, each having VSA adapters showing 2 local storage. So if any one of these storage nodes, any one of these host ESX servers goes down, my data still is represented holistically in a safe fashion by a type of RAID technology that exists in the environment. So still the other features of a virtualization practice, of live migration, high availability, all the other benefits of a virtualization solution can still exist, even though a node is kind of came down with this environment. And you'll quite realistically see, if that node comes down, HA, those virtual machines will automatically get powered up on other systems that are in the environment. Right, so virtual SAN appliances, they're very popular. Now these solutions are really low cost in the environment, and it would be something that I would look at, but of course they are not the most they are not the best performing solutions that kind of exist within an infrastructure. But if you're looking at your environment and you listen to what I've kind of been saying today, that if you have a virtualization practice without shared storage, this might be a way to introduce some of those additional return on investments for your virtualization practice without spending a lot of cash. The next solution that kind of exists is the SAN volume controller, or an SVC. So a SAN volume controller allows us to take multiple storage devices and multiple storage technology and aggregate them together as a single entity. So whether you're using EMC, Equilogix, IBM storage, you can group them together and create one big, large SAN out of them and present that to your IT infrastructure. And it doesn't matter, like I said, if it's Fibre Channel or Iscsi. All the technologies can be consolidated back together. If you needed to, you started off on an HP Iscsi solution, and you wanted to move to an Equilogix Iscsi solution, but you wanted to use the old HP solution as maybe a replication host. You could put an SVC in front of both storage enclosures, take the HP solution, put it at your DR site, and replicate between those two solutions if you wanted to. So again, this is a way of aggregating a bunch of different type of storage technologies and presenting them as a single entity in an environment and replicating them to another storage environment if we needed to. The next technology we should talk about is Converge technology. It's really the next generation of data center technology, especially when we layer on virtualization technology. We really build a data center that's really going to present itself well as we grow our environment. The technology that helps this a lot is something called Fibre Channel over Ethernet. So Fibre Channel over Ethernet is similar in the fashion to what I would like to say is the same way that we kind of presented IP telephony traffic over the same wire as our data traffic. We used to have two separate wires that used to exist, one for our phone system, one for our network connections. We kind of consolidate those down, and then we do voice over IP, so we only have one wire. The same thing is going to be true when we look at our data center infrastructure. Is we're consolidating down our SAN traffic and running that across the same wire as our data traffic in our infrastructure, and we can do so in a prioritized fashion. This technology really relies on 10 gig Ethernet traffic, which is certainly a popular technology and something you should be looking at in your infrastructure. But it allows us to connect up Fibre Channel SANs to our infrastructure and cable once and then rewire later. If we look at the amount of cables that are coming out of our servers in our environment, they can be quite extensive, especially when we look at server virtualization technologies. And I'll kind of give you a scenario. So say we're going to have a VMware server within our environment. I'm going to need a network interface for my LAN traffic. As a matter of fact, I'm probably going to have two network interfaces for LAN traffic. I'm going to need a network interface for my management of the environment. I'm going to need a network interface for high availability or the heartbeat between the different nodes. And then I'm going to need another interface to talk to my shared storage component in the environment. So if you've been accounting with me so far, that's 5 cables that come out of this environment. If I need any type of redundancy, I'm going to double that, so a total of 10 cables. And it's not uncommon to see 6 to 10 cables come out of the back of a virtualized server. So when we stack that up inside a rack, if we use 2U servers, we can stack up 20 servers in a 2U rack. 20 servers times 10, that's 200 cables that exist within our rack. So that becomes very difficult to manage within an infrastructure. If we have to re-provision a server or move it around or find a bad cable that happens to exist in that environment, it becomes very difficult. Not to mention that it blocks a lot of airflow that happens within that rack. So if we replace all those network adapters and replace them with converged network adapters, and these are basically 10 gig network adapters that have the ability to pass Fibre Channel over Ethernet traffic across the same wire. So it has the ability to virtualize host bus adapters in our environment, meaning that I can take this physical adapter and carve it out into, we'll say, 4 network interfaces and 1 host bus adapter. And when I carve it out, and say I installed say I didn't use a virtualized solution, say I just installed Windows 2008. When I booted it up and looked into Device Manager, I would actually see 4 network interface cards and a host bus adapter listed in that infrastructure. And they're virtualized, meaning I could pick those up and move them from host to host. When we talk about topics like boot from SAN, meaning I'm not going to put any local hard drives within a server, and all my data and operating system actually exists on that shared storage, really, if there's no hard drives within a server, and I got those same 20 servers in the rack, what's the difference between each one of those servers? Really, nothing's different between any of them, except, and if you're a technical person, you'll know that worldwide names and MAC addresses will be different between each one of these systems. If I can virtualize those two components, which I'm doing with Converge network adapters, I have the ability to take those connections and move them between systems in the environment. So now I can create a level of high availability for my non-virtualized applications that exist within my infrastructure. So today's environment, I got different network connections for my SAN, LAN, and IPC traffic. We're going to consolidate that down to one set of wires that exist with my IT back room. And when I do that, I can do some pretty amazing things. Say for one reason or another in this diagram, I needed to move the server profile from the first blade in this environment to another blade in that infrastructure. Then I have to do some routine maintenance on that blade, add some more RAM or whatever. I can easily pick up that server profile and apply that to another blade as quickly as I can shut down that system and repower it back up, and it'll be back in production again. Well, say my non-virtualized CRM app fails within an infrastructure. Well, I have the ability to take that server profile and apply that to another blade within the infrastructure, bringing that application back up in the environment. And the same thing could be true for non-virtualized applications as well as a virtualized solution. So I can have a bunch of VMware servers inside this environment, and if one of those VMware servers fails, certainly with the VMware technology, all those virtual machines are going to power up on other physical hosts that are in that environment, but I'm kind of in a degraded mode. How do I get that VMware server itself back into production mode again? Well, I can just reapply that server profile to another blade and bring that back up, and everything will kind of load balance itself back out. So now we're talking about high availability, not only for my virtualized applications, but also for the hypervisor itself, as well as the non-virtualized applications that kind of exist within the environment. Also, if I wanted to take my VMware application and clone it, I could replicate the LUN inside my shared storage technology and assign that profile to another blade, bringing up another VMware server inside the infrastructure. So converged networks are really the core of the next generation data center. You should really, if you're adding onto your data center or expanding your data center or creating a new data center, you should be really looking at these technologies. You need to develop your solutions, for tomorrow's technology. And this technology certainly is here today, right? But you just don't want to be left in the dust. So when we look at this, we're going to find an environment that's going to be easier to cable and manage, less rack and stack with the infrastructure. The whole environment's going to be able to grow and contract, based on your business demands in the environment. These solutions certainly complement a virtualization practice. All shared storage really complements a data center virtualization practice. And we're talking about simplest business continuity for hypervisors as well as non-virtualized applications. So in the end, this gains you a kind of wire-once infrastructure with the environment for your servers as well as your storage with the infrastructure. It's easy to manage. We're managing server profiles against shared storage instead of hardware. It certainly accents your virtualization practice, and it further decouples your critical applications from the hardware that they sit on. So not only your data that exists on the storage decoupled from the hardware, but your processes are also decoupled from the hardware. Okay? And when we combine all these technologies together, we kind of tip that pendulum I was talking about at the beginning of this presentation. Instead of being 70-30 as to just keeping the lights on, you're going to be spending 70% of your time really deploying new applications within your infrastructure and introducing new ideas that will gain your organization a lot of money. All right, so to kind of sum up my storage virtualization talk here today, we're going to lower the cost of management of your entire environment. We're going to make sure your data is really available anywhere and everywhere. Your data is not going to be necessarily coupled to any piece of hardware that exists within your IT infrastructure. You're going to simplify your expansion and consolidation. Remember, you can purchase the storage that you need today, and the throughput that you need today, and grow that as your business demands tomorrow. So it lowers the cost of acquisition in the environment. A SAN, storage area network, you really need that type of solution in place if you really need to get the most out of your virtualization solution. If you have a virtualization practice today and you don't have shared storage, you're not getting the most out of your environment. And finally, some of the technologies that we covered that are kind of leading the way, the virtual SAN appliance. That's the ability to take a virtual machine and present it back to your network as Iscsi traffic in a redundant fashion. And then if you wanted to, you start off that type of solution, you could replicate that solution into a fully redundant array system or a RAIN-based system. So that's the ability to stack multiple storage enclosures together and have them act as a single entity to get more throughput in your environment, as well as expand your storage need in a fully redundant fashion. SAN volume controllers, the ability to take all the storage that exists in your environment from different vendors, from different technologies, and consolidate those down together in a holistic fashion and manage them as a single entity. And finally, replicating your data from your main site to your remote site. Should business continuity be that hard? Why don't we take our entire business continuity strategy and wrap it into a replication strategy so we can protect ourselves even in the worst case scenario. And finally, data dedupe and snapshots. Let's get the most out of the storage that we're purchasing today. Let's make sure it's not taking up more storage that it needs to take up. And with that extra storage, we can take snapshots or backups and mount those to other systems in our environment to further protect ourselves. So that's my entire presentation today. I'd like to hand it back over to Kevin.
Thank you, John. Thank you for an insightful presentation. We actually have a couple questions here queued up. The first one is from Graham, and Graham wants to know, since Iscsi is now a lower cost solution and there are many Iscsi solutions that are available at 10 gig, why would I ever want to consider Fibre Channel based on the current speeds and feeds in the Fibre Channel world?
So certainly it is a very close horse race between the two. I will tell you the Fibre Channel is a little bit faster for the environment. 8 gig Fibre Channel will outperform 10 gig Iscsi in an infrastructure, but realistically it only outperforms it by a little, and it'll be more than enough bandwidth within your environment. Where you really want to look at this type of solution is if you need to boot from SAN in your infrastructure. Currently, Iscsi technology, there are some solutions that are out there that allow you to boot from SAN, but really that's pretty much a Fibre Channel type of solution today. But you need to balance that against the cost that you have, what kind of budget you have in your environment. And by leaps and bounds, Iscsi solutions will be a lot cheaper than Fibre Channel solutions that are available today.
Another question around Iscsi, John. A question here from Brett. Brett wants to know, what is the difference between Iscsi versus FCOE, or Fibre Channel over Ethernet? They both run on Ethernet, correct?
They do. They're just different encapsulation methods. With Iscsi, you're gonna keep your traffic over the Ethernet cable from the server to your storage. When we look at Fibre Channel over Ethernet technology, again, it's still we're encapsulating Fibre Channel controls through standard Ethernet traffic, but we have to go to a device that'll at some point break out our Fibre Channel traffic from our Ethernet traffic. So there's also a Converge Switch that kind of exists, and you'll take this one pipe that'll come out of your server, go into the switch, and then this switch will break. Have network connections, like 1 gig network connections that'll go out to the world, and it'll also have, like 8 gig fiber connections that'll go to your shared storage that kind of exists. So there's similar type of technologies. Again, Fibre Channel you have easier, you can boot from, and Iscsi storage, not so much. It's coming. You're going to see more of it as time goes by. But you need to weigh that against the cost again. Fibre Channel solutions tend to be a lot more expensive than Iscsi solutions exist today.
John, here a question around SAN and SAN in a virtual storage environment. What would you deploy first, a storage area network, or a storage virtualization solution, or a server virtualization solution?
I would probably want to deploy both of them really at the same time. They really rely on themselves. They really complement themselves equally between the two. If I had to pick one, I might pick the shared storage component, so that way I could kind of decouple my data from the hardware that it sits on. It's nice to be able to take a email server's database files or an SQL database files and move that from one server to another if I needed to. It's easy to move partitions around with shared storage. But I think it complements a virtualization practice. They should deploy it at the same time because, although I can move my data around from host to host, I still have an operating system and an application stack that I need to do some business continuity with. And when you combine it with a virtualization solution, holistically, your entire stack from your data all the way down to your operating system, can be created with a level of high availability in it.
You talk about shared storage and virtualization. Here's a question from Dawn, and Dawn wants to know what happens if I use thin provisioning for my storage and my physical storage space fills up.
So you never want that to happen. You will crash your system. They will blue screen if your physical storage is up. So you want to use the alert and monitoring tools that kind of exist and purchase storage and expand your environment. Remember, with a lot of the solutions today, they're going to alert you to the fact that you're reaching capacity, and that you're going to need to add extra storage into your environment. Again, whether that's hard drives or extra storage nodes to expand your environment. So you want to keep an eye on that. I think the best practice for people who are looking to use thin provisioning is maybe critical systems. You might want to provision completely or thickly provision. And then not so critical systems, maybe you want to thinly provision in your environment. So use a mixture. It's another tool inside your toolbox.
Another question around virtualization, this time on the desktop side. What type of SAN technology would you suggest for a VDI deployment?
So evaluate your environments. Your mileage may vary, but I see a lot of people getting away with using Iscsi for their VDI deployments. If you think about it, when users are using their desktops, they're only kind of grazing their hard drives. They're not really hitting their hard drives very efficiently, heavily, I should say. And when you combine that with a bunch of users that happen to be on a floor, they're all using different types of access times, and they're not all using the resource at the same time or the throughput at the same time. So Iscsi tends to be a very good medium when we talk about virtual desktop environments. Not to say that I haven't seen some high-performing environments that require the use of Fibre Channel, but overwhelming, I see a lot of people using Iscsi, especially when we talk about 10 gig Iscsi. I think 10 gig Iscsi, I don't think there's necessarily a position, a VDI deployment that I couldn't do off 10 gig Iscsi.
Excellent. One last question. This one around business continuance. If I set up a site replication strategy, will this eliminate my need for a disaster recovery plan?
There's always going to be a certain amount of work that's going to need to be done at the DR site. If you're replicating the ones and zeros exactly from one side to the other, you're also replicating DNS names. You're also replicating IP addresses. Now, there are solutions out there that could add on to this and change names and IP addressing schemes that you may want to look into, but there's going to be other pieces that you're going to need to do. Somebody's going to have to be able to go in there and say that the database server needs to come up before the web server. The authentication server needs to come up before everything else, and the IPs are on a different VLAN now. So there's always going to be something that's going to need to be done on the remote side, and there are utilities that you're going to want to look to add on. A good utility that's kind of out there for a VMware environment, if you're looking at VMware, is a utility called Site Recovery Manager. But there's other vendors that are out there that are kind of making these type of site recovery tools to be able to automate the process. So I would say it doesn't eliminate the need for something like that, but it certainly reduces your recovery time dramatically. I've seen numbers where people have taken a whole week to bring their environment up, who've moved into a virtualized and replication strategy, and they've brought that same solution back up within a day. And when they layer on some of the tools that I was talking about, like the site recovery managers, they can take that day and cut it down to a half a day.
Excellent. Well, thank you, John. I'd like to thank you for your presentation today. I'd also like to thank all of you in the audience for your participation and insightful questions. I hope this webinar met your expectations. Terakai Corporation will be hosting these regularly, and we'd love your input on topic ideas. Thank you again, and good afternoon.